Hey, what's going on everyone? My name is Tyler and welcome to my channel. Today we're going to be working on variable declarations inside our language and setting the groundwork for types for the next episode. So let's take a quick look at the syntax for variable declarations. It's very similar to JavaScript or TypeScript if you've ever used it. So the first two examples are implicit variable declarations where the type is not defined. This is what we'll be working on in today's episode. And in the next episode, we'll slightly tweak the variable declaration handler to support types. And that also means we'll be creating a whole new type inside of the AST. So we'll have a type node, an expression node, and a statement node. So this is an example of the explicit types. The way the AST is going to be defined for variable declarations is as follows. It will expect the identifier or the variable name, whether it's constant, the value which we actually assigned it, which itself will be an expression AST node. And then, like I said, in the next episode, we'll add a new type node, which will allow us to define custom types. So without further ado, let's actually dive on into the code and see how this is implemented. So the first thing I want to do is go into the examples and create a new language file. So we're going to have 03.lang. And in here, let's define a few variable declarations we'll be able to parse by the end of this episode. So let foo equals 45.5 semicolon. Let foo or let bar equals foo times 10. And let's try something like const is greater equals foo greater than 10, like so. Now, at the end of this episode, we'll be able to parse all this, and then in the next episode, we'll actually add support for types. So we'll be able to create something like let numbers colon numbered equal something like this, and we'll be able to support this type of declaration where we can add explicit types instead of inferred types here. So I'm going to comment these two lines out right here, and we will work on that in the next episode where we actually add types, structs, and syntax for explicit types. So let's go ahead and go into the AST and actually get started by creating the AST for our variable declaration. So I'm going to go into the statements.go right here, and I am going to copy the expression statement, and I'm going to come down below it and create a new one called var decl statement, like so. So this is variable declaration statement. And same thing here, change that. There we go. So what we want to do for a variable declaration is we want to have the identifier, which is just the string. This can also be called the var name or the variable name, like so. Perfect. Then what we want is whether it is constant. So is constant is going to be a Boolean. And then we want to know what was the assigned value. So we're going to come over here and we are going to do assigned value, which is going to be an expression like so. And there we go. In the next episode, we'll then also implement the explicit PLICT type, which will be of type. Now, we're not going to implement that right now, so this we'll have as a to-do for our next episode right here. So now that we have the variable declaration statement set up, what we want to do is actually create a function to parse it. So we're going to go into the parser, and we're going to go to statement.go. I'm going to create a new function called parse var decl statement, like so. Okay, now what is this going to return? It's going to return an AST.statement, and it's going to take in a pointer to our parser. There we go. So what we want to do is, for now, let's just type return var decl statement, like so. Okay, so what do we want to do is go into the lookups now, and inside of here, we want to go down to where we are going to define all of our statements. So let's define all the statements down below all of the expressions right here. So I'm just going to create a whole bunch of space so they're nice and separate. And what we want to do is we want to call statement, and it's going to take in a lexer.kind of lexer.const. And the handler for the const token is just going to be our parse variable declaration statement, like so. Same thing, we're going to want to do lexer.lets, not lets, there we go, and parse declaration statement. So when we encounter a const token or a let token, we want to call this function. And that is it for our lookups.go for this episode. So I'm going to go ahead and close this file. Now, what I want to do is also close the statements.go file as well. Perfect. So the first thing we need to do is we need to determine whether or not we are at a let or a const. As you saw earlier, if we reach a let or a const, both of these functions should be triggered. So we're going to create a variable called is const equals, and what we're going to do is we're going to do p dot advance dot kinds is equal to lexer.constant, like so. So let's explain this again. Is constant is going to be a variable which just represents whether we're a constant, right? This should be a colon, there we go. And then what we're doing is we're advancing past the current token. So we know the current token is const or lets. Whatever that current token's kind is, if it's a const, then we know it's constant, else it has to be a let. So that is that. Now we already know whether we're at a constant. Next, we assume that the next character or next token is always the identifier. There's no way it can't be the identifier. So we call it variable colon equals p dot expect, and let's call expect error this time. And what we're going to do is we're going to say, what do we expect? We'll expect a lexer dot identifier. And the error we're going to give is just going to be a basic string. And we're going to say follow inside variable expected to find variable name. Yeah, exactly. Perfect. So now that we have this, we can continue on. So we have whether we're constant, whether we have the variable name, and this is going to produce a token, but we actually want the value. So we're just going to do dot value. And now this should be a string. Perfect. So we have the variable name. We have whether it's constant. Now what we want to do is get the assigned value out of this. So we're going to do assigned value colon equals p dot, not p dot, parse expression. And we're going to pass in the parser. And then what we're going to do is we're just going to pass in something like assignment, like so. Now, one thing we do need to be careful with is if we look at our syntax, we expect a let or a const, the identifier, but then we also expect an equals or an assignment token, right? So let's quickly do a p.expect lexer.assignment, like so. There we go. So we're saying let and const get handled with this. We get the variable name, we expect an assignment, and then we expect a value. Then all we need to do is do p.expect, and we need to expect a semicolon, like so, right? All of our statements have to be terminated with a semicolon, like so. So there we go. And now all we have to do is return these values inside of our variable declaration. So is constant is const. We're going to have the property for variable name, which is, of course, var name, and assigned value is assigned value, like so. And there we go. Now we have parse variable declaration statements, and we can actually now go ahead and give this a try and see if this works. So I'm going to open up the terminal, make sure I'm in the proper directory. I'm going to do go run source/main.go. And look at that. So by looking at this AST, we can see a few things. We see that the first thing is an expression statement where the expression AST binary, and that is not correct. So let's see why this is not correct. Yeah, let's see. Oh, inside of the main.go, we need to change the file we're reading to be 0.3.lang. And there we go. This looks a lot more like it. So if we look at this, we would expect to see right here, variable declaration statement where the variable name is foo. Perfect. It is not constant, correct. And the assigned value is a number expression of 45.5. Next, we see far, false, and the assigned value is a complex expression, aka binary expression, right? Then we can look at this and see that conveniently as well. We see assigned value, binary expression, foo is is greater is if foo is greater than 10, and it's constant, as we can see, and we can look at the code here and validate that this is indeed correct. So we now have the ability to create variable declaration statement AST nodes. Let me just quickly uncomment this line right here, just to show you that yes, we are going to get an error about this token right here. So let's just run this. And there we go. Panic. Expected assignment, but received : instead, right? So typically we expect an assignment. Here we received a colon. So in the next episode, we'll actually go ahead and implement types. So we'll be able to support two new pieces of syntax. First thing will be struct. We'll be able to say struct vector like this. And then you can say, for example, x is a number and y is a number, like so. And then you'd be able to come in here and say that this is a vector, like so. So you could say this, and this would all be supported. So we'll be able to create structures, which in turn can have types, which could be complex types like a number array or a number array, etc. And then we'll actually be able to support explicit variable declarations using constants and let. So I look forward to coding with you in the next episode. If you like this video, please feel free to like and subscribe and share with your friends. Also check out the Discord server down below. Until next time, happy coding.